Welcome. Again, we're in 4th and 5th grade math. Hi, I'm Mrs. Gaudette.
Hello, mathematicians. I am Mrs. Sears.
And we are here with you on At Home with APS. So we're going to start today on what we finished up last time. So we had at the very end last week, we were reading a book called A Remainder of One by Eleanor J. Prince and illustrated by Bonnie McCain. This book it was about some bugs that were trying to go ahead and divide themselves up into 25 bugs into equal rows. And we had worked on a problem where we had the 25, we started with 2 rows, and poor Joe was off by himself. Then we had 25 divided by 3 rows, and then again, Joe was off by himself. It continued with 4 rows, and then till Joe thought about, why don't we do 5 rows? Another row should work this time. Then after that, I had given you a riddle. That riddle was where I talked about dividing a number by 1, 2, 3, 4, 5, 6, and 7. And then we had some remainders. And based upon that riddle, we had to figure out what number it was. When we did our work, we did 1 through 25. We knew it was a number between 1 to 25. That was my clue I had given you. And we decided based upon those riddles that our number was 10 because 1 could go into it, 2 could go into it, and 5 could go into it. All those numbers could go into 10, were divisible by 5, 2, and 1. So I had left you off where I told you that we were going to do one other thing. In that aspect, we are going to go ahead and look at some numbers, look at a number, and we're going to make our own riddle. So we have here this one as our example. I'm going to flip over and get myself, there we go, to a blank paper. And I'm, again, going to work with a number between 1 and 25. Let me think. 21 would be a good number. So I'm going to start with 21. And we are going to have to come up with a riddle of it. So in that riddle, we should probably do very similar to what we did here to help us out. So if we were to divide 21 by 1, so when you divide my number by 1, the remainder is, any idea? I can hear you guys shouting out at me. The remainder is 0. So if I was to do 2, I'm going to start abbreviating, yes, divide my number by 2, the remainder is 1, right? So I'm going to start, go ahead and abbreviating it even more. So if we divide the number by 3, right? We're going to start with 3. The remainder is 0. Good job. So what if we divided the number by 4? What would the remainder be? All right, so I know that 4 times 3 is 12. Nope, that's not close to 21. 4 times 4 is 16. Okay, that's still not close enough. 4 times 5 is 20. All right, we're close. So what would the remainder be? 1. Now let's try if we divide by 5. What is the remainder? Well, 5 times 3 is 15. 5 times 4 is 20. Ah, there we go. We got it to 20. The remainder is 1. All right, let's try 6. What would the remainder be? And we all know this R means remainder. Good. We have 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. Oh, that's too much, so let's go back to the 3. 6 times 3 is 18, 19, 20, 21. So the remainder is 3. So then let's do 7. What would the remainder be? So let's say 7 times 2 is 14. 7 times 3 is 21. So what is my remainder? Yep, you got it right. 0. So what I would like you guys to do is I'd like you to take this to a family member, our riddle, and hopefully you're keeping track. Remember, every time we do something, you should be writing it down as well. So go ahead and keep track. Have a family member answer this. Then here is my thing for you I'd like you to do, is I'd like you to come up with a riddle of your own that is over 25. This will make it harder for your family members to try to solve that. See if they can solve it, and then can they come up with their own, and you could try to solve it. That's the fun in these kind of things, is we get to work with other people and try to stump our friends. If you've seen me with Mrs. Sears, we always end up trying to stump each other and trying to win. So let's go ahead and try that. Again, give your riddle to your family member. Have them try to solve it. Make up your own one that's over 25 and have a family member try to solve it. Have them try to come up with their own and you try to solve it. That is our ending to remainder of 1. And today we'll be going into a different book, but before that, we're going to be doing, Mrs. Sears, you notice, has joined us back. She's going to start us with a new protocol that we have not done before called Number of the Day. So she's going to work with you on that.
Let me go ahead and get some things in place really quick. All right. So hello again. My name is Mrs. Sears, and I'm going to be working with you on a number of the day. It's very important if you have a piece of paper that you're kind of keeping track of our number of the day, because we will routinely go back to this number of the day and be talking about different characteristics of how that number operates. Okay? We wanted to choose a number that incorporated a decimal today. So let me go ahead and introduce our number of the day. It is 47 and 125ths. Ooh, did I get some of you wet out there? Because I really had to make sure that I said that at the end. Thousandths. Sorry. Oh, let me say that correctly. 47 and 125 thousandths. Yes, want to make sure I say that and really emphasize that, because we're talking about thousandths. Okay? So one of the first things that we always want to do is we want to go ahead and maybe you've seen this chart before. If you have that piece of paper, would you go ahead and write this chart or draw this chart on your piece of paper right now? We're going to put this into its proper place value. This is, of course, a place value chart. You might notice there's a couple of things that are on there already. Some just have initials and some have some words all the way written out. What do you think that T stands for on this chart? If you said tens, you're probably correct. We're going to be talking about how many tens are in that number. What do you think the O stands for? Ah, ones. Yes, ones. We're also going to be talking about how many ones are in that number. But because we're using a number that goes into the thousandths, wow, that's a big number, we're going to also be talking about the other places that go just before that. So the tenths, hundredths, and of course, thousandths. I used to say get your umbrella out because when you say those words, it sounds like it's almost raining on you. All right, so let's go ahead and put those numbers into the proper place value that they belong. And again, our number that we are working on is 47. I'm going to say and here because that's what that decimal means. And 125 thousandths. Okay. So when I say 47, I have to think about how many tens am I talking about when I'm saying that number 47? Well, if I'm looking at the 4, and I know it's in that tens place, I know that there are 4 tens, 10, 20, 30, 40, or 40. 40 would be the 4 tens. So we're going to go ahead and put that in there. And if you would write that in there as we go along as well, too. So the next number that we're looking at is the 7. Well, we know we have 4 tens. How many ones do we have? Oh, 7 ones. Okay, so I'll need to make sure that I put that into the right place value. We have 4 tens, 10, 20, 30, 40, 7 ones. So far we have 47. What do we think is going to have to go into that tenths column? If you said it was 1, you would be correct. We need to say that number as 1/10. It would take 10 of those tenths to make a 1. Okay? It's very important to know that about that too. Okay? So when we're seeing this number so far, if I was going to leave it there and not add on the other 25th thousandths that are on the end of this number, I would say 47 and 1/10 at this point, okay? But I need to go ahead and finish the rest of my numbers. The next number that I would be looking at would be in my hundredths column, okay? I know that from my number 47 and 125th thousandths that I have 2 hundredths in that column. And to top it off, to make my number whole, I'm going to go ahead and put my 5 into that thousands, which is going to make my number 47 and 125th thousandths. All right, this is where it's going to get some trickiness happening here because we're going to move in and out of these digits and these places, and we're going to have to know which of these columns to go to when we do this, okay? So the first thing that we want to do before we go ahead and figure this out is we need to figure out what is 10 more than this number. Well, if I'm going to go to 10 more, I'm not going to go to the tenths column. I want to go to the tens column. Okay, so I'm going to have to really make sure I know what I'm asking for us to be doing. That 10 more is going to mean I need to go to that 10 column and say, what would be 1 more 10 than I already have? Well, I know I have 4 tens. 1 more 10 would be 5 tens, right? Let's write that number. I'm going to go ahead and put 5 tens in there. Do I need to change my ones? No. Do I need to change my tenths? No. Do I need to change my hundredths? No. Do I need to change my thousandths? No. So I better make sure I keep all of those same numbers intact, and my new number with 10 more is going to be 57 and 125 thousandths. Wow, that's just a mouthful to say. 10 less. Can you do it? You got this. I'm sure you do. You're already shouting at me, telling me which one it is going to be. All I've got to do is change what's in that tens column, right? So that tens column is, again, we have 4. We just need 1 10 less. So what's 1 10 less than the 4? Well, let's see. 10, 20, 30. Oh, it's 3 tenths, so 30. We aren't changing the hundredth. we aren't changing the ones, we aren't changing the tenths, we aren't changing the hundredths, we aren't changing the thousandths. Our number would be 37 and 125 thousandths. Okay, here's some more stuff. 100 more. Well, wait, I don't have a column for hundredths. What am I going to do? I think we can do this. If we just have to do 100 more than that, I could create a column over here, but really I just need to add the 100 more in this column to make it work. Let me do that. 100 more. So if it's 47 right now, 47 and 125 thousandths, it's just going to be 147 and 125 thousandths. Perfect. 1,000 more. I don't have any more room to keep going, but I think I can do this. So if I didn't have the hundreds over here, the next place over would be my thousands. I'm not going to have any hundreds in there. I'm still going to have the tens in there. I'm still going to have the ones in there, the tenths, the hundreds, the thousandths. But what am I going to put? I've got to put a 1 in that thousands place. And to make sure that I know I'm saying 1,000, I'm going to put my comma, because I know that comma says 1,000. So 1,000, no hundreds, 4 tens, 40, 7 ones, 1 tenth, 2 hundredths, and 5 thousandths. 1,047, 125 thousandths. Wow, this is just getting to be a mouthful. Finally, something I can change on a different column. 1/10 more. 1/10 more. I do have a tenth column. Let's see. It's right now got 1/10 in there. If I want 1/10 more, I'm going to have to do something to that 1. I'm going to have to increase it. Well, the next number after 1 is 2, but so I guess I can probably do this pretty well. Let's see. 47 and 2, I'm losing my paper, 225 thousandths. Did I do it right? Yeah. What about 1/10 less? Oh, this is going to be interesting. Okay, let's see if I can say this. Let's see if I can do this. Again, we're going to stay in this tenth column. So I have 1/10 there now. I just need to take away one of those tenths. Let's see. If I took away 1/10, then I would have no tenths in that column, right? So I know my 47 is going to stay the same. 47 and no tenths, 25 thousandths. 47 and 25 thousandths. Wow, that's a mouthful. 1/100th more. Okay, my hundredths have a 2 right now. I have 2 hundredths in there. I've got to make 1 more than that, so that 2 would become a 3. Let's see. 47 and 1/10. Let's see, 10, there's 1/10 there, 3. We're going to change that hundredths to that. And the 5 is going to stay the same. Let's see if I can say it. 47 and 135 thousandths. Notice that I'm putting the accent on the very last one that I'm saying to tell me what that numerosity is there. Oh, wow. 100th less. Oh, can I do it, guys? I think I can do it. Okay. 4 is going to stay the same. The 7 is going to stay the same. Our 1/10 is going to stay the same. I've got to go down 100th. So let's see, that's going to make it a 1. And the 5 is going to stay the same. Let's see. 47 and 115 thousandth. Last one. Can we do it? Can we go down 1,000? Let's see. So everything's going to stay the same. I'm just looking at this column and going to go 1,000th less than that. Let's see. 47, 124 thousandths. Wow. That's a huge number and a lot to say in one section here. Oh, is it more? I said it was less, it was more. Thank you for reminding me of that. We need one more than that. So this would have been less. I'm going to just do this. I'm going to say that's the less. Now we're going to do the more down here, right? So I need to actually make that thousandths bigger. So let's see. If it was a 5, it's got to be a 6, right? Because that's going to be the next thousandth up. Okay, 47. Can I do this? And 126 thousandths. Wow. That's some pretty big numbers. All right. We wanted to also think about where this number would belong on a number line. So if you're thinking about this number, we know it's got to be somewhere in between 47 and 48. So, excuse me, we do want to make sure that we kind of figure out or gauge where we think it might be. Right now, as I'm looking at this number, the easiest point for me to find a reference to would be probably to divide this in half. Because I know at this point I would have 47 and 5/10, which would be halfway between 47 and 48. Now, if I keep dividing it by tenths, I'm going to know I'm going to be close to that first one, which is the 1/10 that I want it to do. So let's see if I can find some equal increments in between to make that work. They may not be exactly equal, but they're close enough for right now. So I know that this would be 47 and 1/10. This would be 47 and 2/10. Let's see, 47 and 3/10. Maybe one more over here. I guess we got 47 and, I'm going to run out of space, 3/10. 47 and 4/10. If you can see that way down there. So I know I have 47 and 1/10 already. Now I've got to figure out how could I get 47 and 125 thousandths there. Well, if I know that this is at least a tenth in between, I'm going to probably have, again, 4 more equal parts that are going to need to get me in between that number. Let's see if I can do it. I'm guessing this one is going to be right here. Let's see if I can get another one right here and another one right here. So if this is just a quarter of the distance between that tenth, I would have 4 quarters, so the 25, 50, 75, and then that full tenth to the next number between 47.1 and 47.2. So my number is going to fall right here, which is 47 and 125 thousandths. Let's see. I'm going to make it nice and big because it was hard to find. How would I write that number expanded form? Remember, when we write it out expanded form, we write it out in its correct place value. So we really would have 40, 4/10s, right? 7 plus 7 ones plus, I'm going to go ahead and put a 0 here because at this point we don't have any more ones, but we have a tenth or 1/10 that's going to be added there. So we have 40 plus 7 plus 1/10. What am I going to need to put now? I don't have a tenth there. I have a hundredth. So I have another 0 that's claiming that space. 2 hundredths and 5 thousandths. So how many zeros now? 2 zeros in front of that. And that will make our number of the day 47, 125 thousandths. Wow. Did you get all that? That's a good number to be working with today. We learned a lot about that particular number. I'm just amazed at how well I could speak and say about that number. All right. So hopefully you've got all of that written down, and we want to make sure that you are keeping this journal every day because we will go back to this number of the day as a different routine that we want to keep you remembering what the different places and where the number and the characteristics might be on that chart. All right, the next thing that I would like you to do, and you'll have to get another sheet of paper, but we're going to go ahead and introduce some of our vocabulary that we have today. And the first thing I wanted to have you do is we're going to make a foldable. Foldables are really good tools to be able to remember your vocabulary. So one of the things that we want to make sure that you do with your vocabulary is that we're going to make a foldable. So the first thing we want to do is have a clean sheet of paper. You're going to need some scissors for this. So if you do not have access to scissors and you need to have a grown-up go get that for you, make sure you have a grown-up go get those scissors and that you're able to use those on your own. All right. So we're going to fold this sheet of paper. It's an 8.5, 11 sheet paper. We're going to fold it into hamburger style. Okay, so that if you were looking at it, you just basically folded it in half and you have like one flap that's kind of going to be hanging open. The next thing I want you to do is you're going to use your scissors. Now, make sure you're not cutting the back of the paper, but you're going to use your scissors to make 3 equal flaps, or as close to equal as you can. Those are going to be for your 3 vocabulary words that you're going to use today. So as I'm cutting those, you'll see that I have 3 flaps. This is where I'm going to put my 3 vocabulary words, and I'm going to tell you those in just a minute, in here, and I'm going to be writing their definitions on the inside of this flap. I've already got one ready for you over here, and I wanted to introduce those words today. I think they're back here. Yeah. All right. So if you could, on those flaps that you just made on the very top, could you write these 3 words? They are factor, multiple, and square number. Okay? We're going to talk about each of those words, and we may even be hearing some of them possibly in our story today. Well, I know we're going to be talking more about them today along with our story. So, what is a factor? Have you guys ever heard that concept or that vocabulary term before? A factor? Huh. I've heard it before. I've always heard it when I'm thinking about numbers that are being multiplied by each other, and they make a different number. They make a product of a number. So let me think of how I can formalize that. But a factor is any number that you can multiply, and I'm just going to make an X here because I don't know how much space I have there, but I'll make a little X or asterisk there to indicate I'm going to multiply that with another number. Okay, and that will make a product, to get a product. So if I were going to be talking about factors with 10, I might say that 2 times 5 gets me 10. That 2 and that 5 are both factors of 10 because when I multiply them together, I get the product of 10. Okay? What about a multiple? Well, we've talked about multiples before, and you probably hear multiple when you think of multiplication, right? Because that's what we're doing. We're getting multiples of a number. So multiples, and I'm going to just make a line right here so that you have that little space. So a multiple are numbers that are produced And by a given factor, so we're going to have a specific factor that we're going to use and another number. Okay, so if I'm thinking of specific multiples, let's say I wanted to do multiples of 16. So I would be using that given number to specifically kind of keep using that number again and again to get multiples of that number. So 16 plus 16 would be 32, then we'd have 48, then we'd have 64, then we'd have 80, right? Okay? And one thing I didn't talk about here is that these two numbers right here, they are actually called factor pairs, because those pairs of factors would produce that product, okay? So now we've talked about multiples. We've talked about factors. We have one other type of number that we're going to talk about, a square number. You ever heard of that number? Sometimes you might have heard of something squared, right? All right, well, a square number is any number that is multiplied by itself. That is multiplied by itself. So if you've ever seen, and maybe you have seen this particular drawing, when you're doing area and you see a square, you might have a 3 by 3 square, or perhaps you have a 3 by 3 array. Kind of looks like a tic-tac-toe board, huh? All right. That number, 3 by 3, it not only makes a square, but they call it a square number. So numbers that are squared would be like 9, 16, 25. 3 squared, 4 squared, 5 squared. So keep those in mind, and we're going to have some time. We're going to be talking about a story, and we're going to be coming back to those concepts. So keep that in your brain as far as vocabulary that you're going to want to know is coming up.
Thank you very much, Mrs. Sears. So, every time I see you, I try to bring in a literature book. So this time, we are doing I'm gonna say the word wrong. Liberian, thank you. Off from the side. Miss Sears is helping me out. Liberian, a folk tale. This is called 2 Ways to Count to 10, and it's retold by Ruby D, and it's illustrated by Susan Maddow, and it is published by Henry Holt Company. And in this, as we're going through, as always, be thinking about what math is happening in this story. Long, long ago, animals were not so different. One from the other, they were different colors, shapes, and sizes, just as they are today. But they lived together in friendship and in peace. The leopard was king, rich beyond telling, mighty in his power and wisdom. All the animals respected and loved their king. Who shall I name to rule after me when I die? King Leopard said one day to his beloved daughter. I must seek out the cleverest beast in our jungle. I must find one who is wise enough to rule well. I shall make him a prince. Someday, my dear daughter, the 2 of you shall be queen and king. King Leopard was pleased with his idea, and he planned a great feast. His royal drums carried the news of the feast far and wide throughout the jungle. All the animals came as guests, and they danced for 3 days. At last, the king told them to make a huge circle. Stepping into its center, he called his daughter to his side. Then he spoke in a loud voice. Listen, friends, he cried. Someday, when I am gone, another king must rule in my place. I will choose him now from among you. From among you so that he will be ready. There was a mutter of excitement all through the crowd. I shall seek the cleverest among you, for your king must be wise. He shall be a son to me and a husband to my dear daughter. He shall share all my riches. Shouts came from the eager guests at the king's feast. No doubt each animal hoped that the good fortune would be his. Then King Leopard held up his hunting spear. Look at this, my people. Watch. He flung the spear far up into the air and caught it when it fell to the earth again. With this spear, I will test you. He who would be our prince must also throw the spear towards the sky. He must send it so high that he can count to 10 before it comes down again. There was a buzz of talk among all the animals. This would not be so hard to do, they thought. One after another, they came forward to try their skill. But first, each beast danced and sang before the king and his daughter. I will be first, said the elephant, pushing all the other beasts out of the way. The elephant danced clumsily. He was very big, and his body was heavy. With his trunk in the air, he trumpeted all the fine deeds he would perform if he were king. I will be king. I can do this thing, he said. With his trunk, the great beast threw King Leopard's spear into the air. 1, 2, 3, he began counting. But before the elephant said 4, the king's spear dropped to the earth. The proud beast hung his head so low that the tip of his trunk dragged on the ground. He had failed. Next came the bush ox. I will be king. I can do this thing, said the huge animal as he danced. I'll throw the spear to the sun. The bush ox picked up the spear in his mouth. With a mighty toss of his great head, he flung it far, far above his wide gray horns. 1, 2, 3, 4, the bush ox counted, but he too was slow. Before he could say 5, the spear was down on the ground, and he went off, ashamed, into the jungle. The chimpanzee was third. He jumped up and down, beating his hairy chest with his fist and singing of how much he would like to be king. The chimpanzee rose up on his hind legs and held the spear in one hand, just like a man. I will be king. I can do this thing, he said. With a twist of his long arms, he threw it up in the sky. 1, 2, 3, 4, 5, 6, 7. He chattered as fast as he could. The animals held their breath. Surely, with such a quick tongue, he would make the count. But he did not. Just as he said 8, the spear fell into his hands. Then the crowd parted as the lion stepped majestically into the center of the circle. The lion had always wanted to be king anyway, and now was his chance to prove that he was the finest animal in the jungle. With a fling of his mighty mane, he danced and sang of his royal intentions. I will be king. I can do this thing, he sang. And as the other animals looked in awe, the lion twirled his mane around the spear and threw it skyward with a thunderous roar. 1, 2, 3, 4. The spear rose higher and higher. 5, 6, 7, 8, 9. Just as he said 9, the spear pierced the earth at his feet. The lion was furious. Off he stomped into the bushes. One by one, the other animals tried to count to 10 while the spear was still in the air. One by one, they all failed. It seems I must look somewhere else for the beast who is clever enough to rule when I am gone, King Leopard said sadly. Let me try to throw the spear, O king, came a brave voice from the crowd, and out stepped the slender antelope. I will like to marry your beautiful daughter. I will be king. I can do this thing. Ho, 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 ha, ha, ha. The other animals broke into laughter. How could this weak and puny creature possibly throw the king's spear high enough to count to more than 2 or 3? How could he hope to succeed where all the other animals, even the lion, had failed? But the young antelope would not be turned aside. I wish to try, he insisted. King Leopard nodded his head. Who can say what any creature can do until he has tried? The king said to the crowd. The antelope may throw the spear. So all the other animals moved back to give him room. When the antelope danced, King Leopard's daughter was very pleased. No one could deny that his steps were more graceful than all the other animals' steps. With a toss of his head, he flung the spear far up into the air. Before it could fall to the earth, he called out 5 words. 2, 4, 6, 8, 10, he cried. I have counted to 10. King Leopard did not say how the count was to be made. The king laughed and nodded his royal head. No, I did not say how the count was to be made, he agreed. And as everyone knows, one can count to 10 by 2s as well as by 1s. Remember, my friends, it is not always the biggest or the strongest, but sometimes the cleverest that wins the prize. The antelope has won the contest. He shall be king. At the wedding feast, which King Leopard gave for his daughter, the animals all cheered their clever new prince. So that was the book on 2 ways to count to 10. Do you have any idea what math might have happened in that book? Yeah, right? We counted to 10. So we counted to 10. And my question to you is, what are the different ways that we can count to 10? Right? I'm hearing you guys. I hear you. So we can count to 10. Oop, I'm trying to find a marker. There we go. We can count to 10 by 1s, right? That's what all the different beasts were doing at the very beginning. Then we know the antelope counted by 2s. What are some other ways that we could count to 10? Right? We can count by 5s. 5, 10. I'm not hearing the last way. Oh, there we go. The other way we can count by 10 is just by saying 10. Those are all the different ways that we can count by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was fast, right? Just like the lion or the chimpanzee was trying to talk really fast. Can count by 2s like the antelope. And then the 5s and 10. Now, my question to you is, can we count to 10 by threes? 3, 6, 9, plus 1. Will that work for us? No, it won't, right? Because if we were doing a logical sequence, a pattern, and that's what these are all about, is patterning. If we were to do that, 3, 6, 9, the next one would be 12. We can't just randomly do a plus 1 or a minus 1 or whatever we need to do just randomly out of the air. It has to be a logical pattern. So, if we do that, what do we predict? All right, so today we're going to investigate how we can count by different ways to count to different numbers. So I have here a chart that we'll start with, that we have all the numbers 1 through 10, and then I have all the numbers 1 through 20. And we're going to try to figure out how to count to these numbers. So let's look at 12 really fast. If I had 12, what ways would I be able to count to 12? Well, I know I can count by ones, and I can do that 12 times, right? Right? I'm hearing it. You can count by twos. And how many twos would we have? It'd be the 6 words, right? Just like the antelope had 5 words. There was 5 of those twos in there. Would there be any threes? Yeah, 3 times 4 would also get us 12. So I know that I got all of them because 3 and 4 are right next to each other. So that works out perfectly. If I was to go in here, you notice my chart. I'm going to move this over just a tad. My chart says here that I have the number 1 through 10. I have the ways I can count to that number, which are also, a reminder on our vocabulary, is our factors of a number. And then the number of ways. So if I was to start with 10, I would have my 1, my 2, my 5, and my 10. And then how many ways would I be able to count to 10? 4, right? So we have the 1, 2, 3, 4 of them. There's 4 ways, or 4 factors, bringing in those vocab words. Keep bringing them in. And then we did 12 as an example. You notice I wrote mine really odd. When we're writing our factors, we don't write it like this. We write it with the commas in between the numbers. So on 12, I'd have 1, 2, 3, 4, 6, and 12. And how many factors are there? How many ways were we able to do it? 1, 2, 3, 4, 5, 6. So what I'd like you guys to do is we're going to do together figuring out what are all the factors of all of our numbers. Because this is great information that helps us later on when we're trying to do division, when we're trying to really look into and figure out equivalent fractions or to reduce our fractions, any of those things. This information is very helpful. So what we're going to do is we're just going to start listing them. On number 1, what are the factors or the ways to count to 1? Right? There's only 1. We can only count to 1 by 1. So we have 1 way. How about 2? We can count to 2 by 1s, and we can also count by 2. And how many ways is that? 2 ways. How about 3? Right? Just 1 and 3. And then again, just our 2 ways. How about 4? Right? I'm hearing you. We can count by 1s. We can count by 2s. Can we count by 3s? Nope, there's not that predictable pattern. And then we have 4. So that would be 3 ways. How about 5? Just 1 and 5. I'm recognizing something. Are you? Let's talk about it in a second. How about 6? So we can do by 1 multiplied by 6. Here's another way. Sometimes that will help me. I can do what I call a rainbow. 1 times 6. What else could we do? Right? We have 2 times 3, and that's my other rainbow. Do I have anything in between here? No, because we're talking about whole numbers when we talk about factors. Now 7, 1, 2, 3, 4. Might as well add that in. Right, I heard you guys had already started to tell me that answer before I even had a chance to finish off the other one. And we had 2. What about 8? I'm one of the ones who likes to do the multiplication. But, with 8, we have our 1 times our 8, our 2 times our 4. Can we do 5? No. Can we do 6 times anything to get 8? No. What about 7? No. So there are, you notice it's a little further apart, but that's okay. So we have our 4 ways that we're able to do that. How about 9? 1 times 9 and 3 times 3. Can we do it any other way? No. 4 doesn't work, 5 doesn't work, 6, 7, that's it. How about 11? So we have our just 1 times 11. Perfect. It's 2. So now I have done the easy ones. Now we're going to start with some of the others. 13 was 1 times 13, which is 2. And then I'm going to start giving you some new ones. And in that, we have the 14, 1, 2, 7, 14, which would be how many ways? 4. Then we're going to bring in 15. Ooh, 15 looks like it has a few also. And how many is that? 1. 3 times 5 and 1 times 15 is our 4. Let's do 16. We have 1 times 16, 2 times 8, and that 4 times 4, which gets us our 16. So I have 1, 2, 3, 4, 5 factors of 16. Now 17. Let's look at 17. It's only 1 in 17. So how many factors is that? 2. What about 18? Ooh, we look like we're starting to get those bigger numbers here. We have 1 times 18, 2 times 9, 3 times 6, which gets us how many factors? 1, 2, 3, 4, 5, 6. All right, 19. You're going to laugh because, yep, you're right. I heard it. There's only those 2. 1 times 19. That's the only way to get that. That's 2. How about 20? Yeah, I heard it. You're all, it's even. There's going to be a lot of factors. You're right. So we have 1 times 20, 2 times 10, and 4 times 5, which equals how many? 1, 2, 3, 4, 5, 6. All right. So let's look at this for a second. What are some patterns you're noticing here? Because this is only 1 through 20 and the factors of them. So what are you noticing so far? Right? Every even number has more than 2 factors, except for 2. And why doesn't 2 have more than 2? It's prime. So what does that tell us about the 2 factors? Is if you only have 2 factors, what is it? Prime numbers. Now, last time we met, I misspoke about something. I had said 1 was a prime number. 1 is not prime or composite, and so I want to make sure I clarify that. It's kind of off by itself. Starting with 2 is our first prime number. What I'd like you guys to do is, over the course of the next day or so, I'll see you on Thursday, is I want you guys to come up with the factors from 21 to 49. And we'll continue with this next time we see each other. And again, my name is Mrs. Gaudette, and you also had Mrs. Sears with us. And I would like to thank you all for joining us today on At Home with APS. Have a great day.